What is quantum entanglement? Quantum entanglement is a phenomenon observed at the quantum scale where particles become interconnected so that the state of one particle cannot be completely described without considering the state of the other, no matter the distance between them. This link persists even if the particles are separated by vast distances, a feature Albert Einstein famously referred to as spooky action at a distance. To understand entanglement, it's useful to know a bit about quantum states. In quantum mechanics, particles like electrons or photons can exist in multiple states simultaneously, a concept known as superposition. For example, an electron in a superposition state can be simultaneously in a state of spin-up and spin-down until it is measured, at which point it randomly collapses to one of these states. When two particles become entangled, the quantum state of each particle cannot be described independently of the state of the others. If you measure the state of one particle, you instantly determine the state of the other, no matter how far apart they are. This instantaneous connection seems to defy the classical idea that nothing can travel faster than the speed of light, although entanglement does not actually allow for faster-than-light communication or information transfer, thus obeying the principles of relativity. Entanglement is not only a fascinating aspect of quantum theory, but also a potential resource for emerging technologies such as quantum computing, quantum cryptography, and quantum teleportation. In these applications, the properties of entangled particles can be used to perform tasks that are impossible for classical systems, such as computing certain types of problems much faster or enabling secure communication that can be proven to be secure by the laws of physics. Does it have any religious or philosophical implication? Quantum entanglement and quantum mechanics more broadly have indeed stirred discussions and debates in both philosophical and religious contexts. These implications arise primarily from how quantum mechanics challenges classical intuitions about the world, such as the notions of locality, that objects are only directly influenced by their immediate surroundings, determinism, that events are caused by prior events, and the nature of reality itself. Philosophical implications. Reality and objectivity. Quantum entanglement raises questions about the nature of reality. In classical physics, objects are thought to have inherent properties that exist independent of observation. In contrast, quantum mechanics suggests that the properties of entangled particles are not definite until they are measured. This has led to various interpretations of quantum mechanics, each with different philosophical implications about the nature of reality and whether it is objective or dependent on observers. Determinism and causality. Traditionally, the universe is seen as a causally deterministic system in classical physics, where the future can theoretically be predicted perfectly if all initial conditions are known. Quantum mechanics introduces an element of randomness at the fundamental level, for example, the exact outcome when measuring a quantum state, which challenges deterministic views and has implications for how we understand cause and effect. Locality entanglement seems to suggest that information or effects can be transferred instantaneously over any distance, apparently contradicting the principle of locality upheld by the theory of relativity. This challenges our traditional notions of space and time and has led to philosophical debates about the connections between distant objects in the universe. Religious implications. Free will. Some religious and spiritual interpretations have used quantum mechanics to argue for the existence of free will, suggesting that if determinism is not an absolute rule at the quantum level, there might be room for free will in the universe. However, whether quantum indeterminism can be scaled up to human decision-making remains highly controversial and speculative. Interconnectedness. The idea that all parts of the universe are interconnected at a fundamental level through phenomena like entanglement can resonate with certain religious or spiritual views, such as in Hinduism and Buddhism, where interconnectedness and the non-independence of phenomena are key concepts. The role of consciousness. Some interpretations of quantum mechanics, like the Copenhagen interpretation, place the observer in a pivotal role, leading to speculative suggestions that consciousness itself might play a fundamental role in the workings of the universe. This idea has been appealing to various spiritual and New Age perspectives, which suggest that the mind or consciousness can influence reality directly. While quantum mechanics has sparked these and other discussions, it's important to note that the scientific theory itself does not address spiritual or metaphysical questions directly. Instead, it offers a framework for understanding physical phenomena at the smallest scales, which philosophers, theologians and thinkers have interpreted in various ways to explore broader existential and metaphysical questions. In simple terms, quantum entanglement can be a challenging concept to grasp, especially because it involves aspects of physics that are outside everyday experience. Here's how to explain it in simpler terms. Imagine you have a pair of magic dice. When you roll them together, no matter how far apart they are from each other, even if one is in your house and the other is on the moon, they always show complementary results. If one die shows a 6, the other will show a 1. If one shows a 5, the other shows a 2, and so on. The outcome of one die instantaneously affects the outcome of the other. In the quantum world, entanglement works somewhat similarly. You can think of entangled particles as pairs of these magic dice, but instead of numbers, they deal with quantum properties like spin or polarization. When one particle of an entangled pair is measured and shows a particular state, like spin-up, the other particle, no matter how far away, will show the opposite state, spin down, immediately. This strange connection challenges our usual ideas of how objects behave based on everyday experiences, where actions at one location don't instantaneously affect distant objects, a principle known as locality. In the quantum world, however, these entangled particles act as if they are instantly connected, regardless of the distance between them. This phenomenon doesn't mean information travels instantly or faster than light, which would violate Einstein's theory of relativity. Instead, it suggests that these particles are so deeply linked that their properties are inherently dependent on each other, reflecting a profound and fundamental nature of the universe that we are just beginning to understand. In conclusion, quantum entanglement is a fascinating and deeply mysterious phenomenon of quantum physics where pairs or groups of particles become so interconnected that the state of one cannot be independently described without considering the state of the others. This interconnection remains no matter how far apart the particles are, challenging classical notions of locality and causality. Entanglement not only pushes the boundaries of what we understand about the nature of reality, but also has practical implications. It underpins emerging technologies such as quantum computing, quantum cryptography, and quantum teleportation, which could revolutionize computing, secure communication, and numerous other fields. The philosophical and potential religious implications of quantum entanglement invite us to reconsider fundamental questions about determinism, interconnectedness, and the role of the observer in the universe. Although these discussions extend beyond the empirical scope of the science, they highlight the profound impact that understanding the quantum world can have on broader aspects of human thought and belief. Please like, share, and subscribe for more videos like these. Also, let us know in comments any subjects you're interested in. Thank you.